Okay, good evening. It's nighttime here in the Philippines. My name is Felipe Lu. I'm currently the Vice President for the Organization of Power Plant Specialists Incorporated, or OPPSI. I will render the presentation in behalf of the group. Allow us to enlighten you on the topic entitled the Philippine Power Industry. This is the outline of our presentation. The first bullet is the structure of the Philippine power industry, then followed by 2019 power demand and supply situation, power generation by source, a brief look of type of power plants in the Philippines, and the last bullet is the role of mechanical engineers in power generation. Before anything else, let's have an appreciation of the structure of the Philippine power industry. Before the Electric Power Industry Reform Act, or EPIRA, was passed into law, the power industry was run by the state, and it was vertically integrated because the government controlled National Power Corporation, both own and manage the generation and transmission of electricity of the entire country. After the EPIRA, the power business was privatized and split into generation and transmission business. Now, as shown on the graph, allow me first to explain the flow of electricity, which is represented by the black arrow from the power plants of the independent power producers and public sector assets and liabilities management corporation, or PSAM generating assets, to the transmission towers, which is being managed by the National Grid Corporation of the Philippines, or NGCP, and finally to the consumers. Now, the structure is subdivided into policy, regulation, institutions, generation, market, transmission, distribution, supply, and the end user or customers. The Department of Energy is the executive department of the Philippine government, responsible for the governance and developing policy for the power industry. The Energy Regulatory Commission, or ERC, is an independent body responsible for regulating the power industry and, among other duties, is responsible for approving bilateral power supply agreements, ancillary service procurement agreements, and setting the distribution wheeling rates of distribution utilities and electric cooperatives. The National Electrification Administration, or NEA, is government-owned and controlled corporation responsible for promoting full electrification in the Philippines with a focus on the numerous electric cooperatives that tend to serve the less developed areas. Under the group of generation are the independent power producers, or IPPs, and PISAM. PISAM is responsible for selling both government-owned power generating assets and long-term power purchase agreements, or PPAs. Now, for the market, the Philippine Electricity Market Corporation, or PEMC, governs the wholesale electricity spot market, or WESM. It serves as the autonomous group market operator and governing body of the WESM. The PEMC transferred the operations of the power bourse to the Independent Electricity Market Operator of the Philippines, or IEMOP, on September 26, 2018, retaining its governance function over the WESM to ensure that there is power, efficiency, market, and competition in the energy industry. Now, the independent market operator operates the Philippine Wholesale Electricity Spot Market, or WESM, as the independent market operator, or the IMO, in close coordination with the system operator, or SO, of NGCP. Now, the independent market operator is responsible for the commercial aspects of WESM transactions, while the system operator takes care of the physical implementation of these market transactions. The independent market operator runs the electricity market by, among other things, managing the registration of market participants, receiving generation offers, coming out with market prices and dispatch schedules of the generation plants, monitoring the day-to-day market trading, and handling billing settlement, and collections. Now, the next layer is the transmission business. The transmission network is still owned by the state. Initially, the transmission network was operated and managed by Transco or Transmission Corporation, a state-owned company, created also by the EPIRA law. But eventually, following a public bidding conducted in December 2007, the Transco concession was awarded to the National Grid Corporation of the Philippines, which eventually secured a congressional franchise to operate the transmission network through RA 9511. For the distribution business, the players are Meralco, other private investor-owned utility, and electric cooperatives. Next to the distribution business is the supply business. In addition to Meralco and electric cooperative or electric cooperatives is another player, the retail electricity suppliers. The electricity or the retail electricity suppliers is any person or entity authorized by the ERC to sell, broker, market, or aggregate electricity to the end users. For the end users, there are two types of customers. The captive customers is an electricity end users who do not have the choice of a supplier of electricity, whereas the contestable customer is an electricity end user who has a choice of supplier of electricity as determined by the ERC in accordance with the EPIRA law and the rules for contestability. Okay, let's move on to the 2019 power demand and supply situation. Okay, allow me to discuss the power demand and supply situation in 2019. Now, let's start with the peak demand. What is the significance of peak demand of the country? In 2019, the peak demand is pegged at 15,581 megawatt. Now, the supply, either installed or dependable capacity, the total capacity of all the power plants connected to the NGCP grid, must be greater, including at least 25% reserve capacity, and must exceed the peak demand at all times. If the supply will not be able to match the peak demand, expect a power interruption from time to time, a situation which we don't want to happen. Now, the dependable capacity of the country in 2019 is 22,736 megawatt out of the installed capacity of 25,531 megawatt and is greater than the peak demand. Now, there's an increase in peak demand compared to 2018. The peak demand of Luzon, Visayas, and Mindanao went up by 4.3%, 8.3%, and 8.6% respectively. Now, let's talk about the electricity consumption or gross generation. Now, consumption will always be equal to generation because electricity has to be supplied at once when needed. Almost all electricity is used instantly as it is generated. Now, electricity consumption or gross generation in 2019 is 106,041 gigawatt hour, and topping the list of consumer is residential, industrial, and commercial respectively. Okay, now let's take a look on where those gross generation of 106,041 gigawatt hour are coming from. Now, most of the generated electricity was produced from coal-fired power plants. Now, the next second producers of electricity are renewable energy, consisting of hydro, geothermal, solar, wind, and biomass in that order. The third producer of electricity is natural gas power plants, and followed by oil-based plants. Now, our takeaway from this slide is that from the perspective of energy security and environmental protection, the Philippines must increase its investment in natural gas and renewable energy, primarily on the geothermal power plant, to sustain our baseload requirements as well as address climate change. Now, okay, for the renewable energy, which is dominated by hydro and geothermal, the installed base of hydro is at 60%, whereas geothermal power plant is at 20%. The edge of geothermal power plant over the other renewable energy, except biomass if there's an ample fuel supply, is that it is base load plant, meaning it is running and producing electricity 24/7. Okay, now there are generating assets that are not connected to the main grid. These are off-grid, consisting of 279 islands that must be provided with electricity. The peak demand of the small island is 302 megawatt and installed capacity is 526 megawatt. Now the fuel type used by these power plants are mainly oil-based, hydro, wind, and solar. Of the 1,623 gigawatt hour generated in 2019, 94.8% is supplied by oil-based power plant. Okay, one important thing that need to be highlighted about the power situation of the country is the Philippine grid, which will interconnect the three main islands of the Philippines, Luzon, Visayas, and Mindanao. Now, with the Philippine grid, excess electricity from Luzon will be exported to Visayas and Mindanao and vice versa. Luzon and Visayas grid are already interconnected since August 1998, whereas the Visayas and Mindanao grid will be interconnected in December this year. The interconnection through a submarine cable will be from Dapitan City, Zamboanga del Norte to Santander in Cebu. And let's hope and pray that the interconnection of the Philippine grid will be realized soon. Okay, for the capacity expansion or additional power plants until 2040, the Philippines, according to the Department of Energy, will need 62,248 megawatt or additional of 2,800 megawatt per year to sustain the economic growth of the country. For this year, the GN Power Dinginin in Bataan, the first unit of which around 668 megawatt, will be online on the last quarter of this year. And the second unit, another 668 megawatt, will be synchronized to the grid on the second quarter of next year. Let's proceed with the power generation by source. Power which we use every day comes from various sources and for various reasons. One is economics, affordable power. The other reasons are stability, security, and reliability. That is why we need power plants not only running in coal, but also other fuel types. We also need a robust transmission and distribution lines so that power generated somewhere very far from urban areas would be available at the instance we need them 24/7. Okay, this is a typical coal power plant process. Now, the main component of a coal-fired power plant is the boiler or steam generator, the prime mover or the steam turbine that drives the alternating current generator. Now, coal from stack pile is transported through a conveyor to the coal pulverizer before the coal is burned in the boiler. Now, the high pressure, high temperature, superheated steam from the boiler flows to the steam turbine for conversion of the energy of the steam to mechanical energy that drives the AC generator for kilowatt-hour production. A coal-fired power plant is equipped with a catalytic reactor for NOx control, a precipitator, and the SO2 scrubber. The application is depending on the technology adopted by the coal power plant to ensure that the air emissions discharged from the power plant smokestacks complies with the environmental law. Now, after the coal-fired power plant, let's move to the next technology or type of power plant, the gas turbine heat recovery steam generator combined cycle power plant. This is a typical natural gas power plant process. This plant can also use a liquefied natural gas or LNG, a natural gas in liquid form, but you need to equip the LNG power plant with a regasification unit to transform the LNG to natural gas. Now, like coal power plant, the natural gas power plant has a boiler, but it is called a heat recovery steam generator. For this technology, the gas turbine is on the side of the heat recovery steam generator, and the steam turbine is on the other side. Both are coupled to a common generator. Okay, here is an animation of the gas turbine during startup until both the gas turbine and steam turbine are coupled to a common generator and all these components are aligned, engaged, synchronized, and running at your rated speed. Now, during startup, the generator acts as a motor by a startup frequency converter or SFC for heat recovery steam generator purging for 10 minutes and start up the gas turbine. Now, once all the burners of the gas turbine are flame on and gas turbine speed is around 80% of its rated speed and combustion self-sustaining, the startup frequency converter will cut off once its rated speed and synchronization are achieved. This time, the steam turbine is still on turning gear and waiting for the correct steam, quality, and startup parameters. Now, once the conditions are met, the steam turbine will be running up and it's almost at the rated speed. The synchronous struts connecting the steam turbine side of the generator will engage and thereby increasing the generator output. Okay, this is a hydroelectric power plant, including the dam, watershed, the upstream behind the dam, downstream after the powerhouse, and the spillway for the release of excess water from the dam caused by too much rain in the area. Okay, this is the hydroelectric power plant process. There is no boiler to convert water to steam. The plant has a water flow through a penstock from an upstream or higher elevation to lower elevation. The three forms of energy given by Bernoulli's theorem in the volume of water flow are transformed into electricity through the turbine generator. Okay, this is a geothermal facility up in the mountain with forest cover around the power plant. In a geothermal power plant, it has a fluid collection system where it processes the geothermal steam coming from below the surface of the earth in a geothermal reservoir via the production well. From the production well, all the geothermal steam flows to the separator to remove the liquid from the steam. The dry steam is diverted to the geothermal steam turbine to drive the AC generator for the production of electricity, whereas the separated liquid from the separator flows back below the surface of the earth via the reinjection well. Now, some of the liquid from the main condenser of the power plant also flows back to the reinjection well for recycling. Now, for environmental protection and compliance with the law, all geothermal fluid above ground must return to the earth through the reinjection well. Okay, this is the fluid collection and recycling system of a geothermal steam field. Now, the production well and the reinjection well must not be very near to each other, but near enough so that the returning geothermal fluid could replenish the geothermal steam source or reservoir over time. Okay, the fluid collection and recycling system has 4 sub-processes: collect geothermal steam from the earth through the production well, separate the two-phase steam through the separator vessel, convert the dry steam going to the power plant for electricity production, recycle the brine and geothermal fluid by returning it back to the earth through the reinjection well. Okay, some more representation of the geothermal steam field and power plant. Now let's start with the reservoir about 3 kilometers below the Earth's surface. The reservoir fluid is at 250 degrees C. Then steam move up from the Earth through the production well. Then the two-phase liquid is channeled to a separator vessel to remove the liquid and divert the geothermal steam to the steam turbine of the power plant. And then the geothermal fluid returned to the earth through a thermal pond and the reinjection well. Okay, from the experience of one of the power producers in the Philippines, it takes them 7 years to commission a geothermal project, 3 years exploration, and 4 years development, including power plant construction. Power production is 25 to 40 years. Okay, the next type of power plant is the wind turbine power plant. We have a group of wind turbines in the same location used to produce electricity. Now, okay, this is a simplified representation of wind turbine power plant. Though the nacelle sits atop the tower and contains the gearbox, low and high speed shafts, generator, controller, and brake. Now, wind at a certain acceptable speed turns 2 or 3 propeller light blades around a rotor. The rotor is connected to the main shaft, which spins a generator to generate electricity. The wind turbine has a speed system that turns or pitches blades out of the wind to control the rotor speed and to keep the rotor from turning in the winds that are too high or too low to produce electricity. The yaw system orients upwind turbines to keep them facing the wind when the direction changes. Okay, this is a diesel power plant. The prime mover is an internal combustion engine that burns diesel fuel or bunker fuel to drive an AC generator to generate electricity. This is a typical diesel power plant process. On the right side of the slide is 16-cylinder B-type internal combustion engine. It drives an AC generator to generate electricity. To run reliably, a diesel engine will need a fuel system, compressed air system, lube oil system, cooling system, and exhaust gas system. The diesel power plant is capable for quick start and could be operated as base load plant or as peaking plant. Peaking plant is a power plant that generally runs only when there's a high demand of electricity for a short time. This is a biomass power plant process. Those biomass power plants in Nueva Ecija utilize a rice husk as fuel. Now there's a preparation and processing of the rice husk before it is fed to the furnace or boiler. Boiler will generate the steam to drive the turbine generator for the production of electricity. Okay, we will have a virtual plant tour of types of power plant in the Philippines, and then we will visit the coal-fired power plant, combined cycle power plant, hydroelectric power plant, geothermal power plant, diesel power plant, wind turbine power plant, and biomass power plant. Although the first unit of this coal-fired power plant was constructed in 1984 and the second unit was in 1995, the power plant is well maintained. The smokestack is well painted. The electrostatic precipitator is beside the boiler. The coal unloading facility is near Balayan Bay in Batangas. The coal yard is covered for safety and compliance with the environmental laws. Then we have NGCP switchyard to receive power generated by the plant and to be transmitted to the consumers. Okay, this is a 2 by 150 megawatt circulating fluidized bed or CFB coal-fired power plant of Southwest Luzon Power Generation Corporation in Calaca, Batangas. The high efficiency of the coal combustion process of circulating fluidized bed or CFB boilers control CO2 emissions. Now the CFB technology make use of limestones to absorbs and reacts with SOx gas. NOx emission is also controlled. Okay, this is a typical setup of some of the air pollution control equipment of a coal-fired power plant. The electrostatic precipitator and flue gas desulfurizer are located in between the boiler and the smokestack. Now, ESP is a filtration device that removes fine particles like dust and smoke from flowing gas. The flue gas desulfurizer is installed to control the SOx emission by spraying or scrubbing the flue gas with limestone slurry, whose magnesium oxide content absorbs and reacts with SOX to form a stable substance, gypsum. Okay, let's have a virtual tour of the combined cycle power plant. This is an image of a combined cycle power plant. There are 6 smokestacks, which means that there are 6 heat recovery boiler or steam generator for this facility. Okay, we have another view of the combined cycle power plant. We have the heat recovery steam generator, and then the gas turbine generator and steam turbine are grouped in one area. Okay, this is the gas turbine of the combined cycle power plant, and it has 4 components: compressor to supply the high pressure air to the combustion chamber, the burner, and the turbine. Okay, let's proceed to hydroelectric power plant for the virtual tour. This is an aerial view of the water reservoir of the hydroelectric power plant. We have the upstream, then we have the dam, and then we have the spillway. Okay, the picture is showing a pulled out Francis turbine for inspection and cleaning during a major overhaul. A hydro generator rotor was pulled out from the AC generator for cleaning, inspection, testing, and maintenance. Now this is a control room of a hydroelectric power plant. This is the Ambuclao hydroelectric power plant built in 1956. Displayed outside the plant is the original turbine runner, the Francis turbine. At the back is a tunnel going to the powerhouse. Now, the Ambuclao Hydro was owned before by the government. After the EPIRA law, it has been privatized and modernized. This is the new horizontal turbine of the Ambuclao hydroelectric power plant. The old turbine is 25 megawatt, and the newly installed turbine is now 30 megawatt. Okay, let's have a virtual tour of the mountainous area of geothermal power plant. Okay, this is a geothermal power plant at Mount Apo in Mindanao. The elevation of the power plant is about 1,500 meters above sea level, whereas the height of Mount Apo is 2,954 meters or 9,692 feet above sea level. Okay, this is a drilling rig for a new production well. There's science to it. You just don't drill anywhere on the surface of the earth. The geothermal steam must not be too corrosive and could be used by the current technology. The reservoir must be able to supply geothermal steam for at least 25 years for a given plant capacity. Okay, here's a view of the production well for the geothermal steam from the source or reservoir. Okay, this is the reinjection well for the returning brine or geothermal fluid. The separator vessel that separates the brine to generate a dry steam. Okay, this is a typical setup of a geothermal power plant. It has a cooling tower, powerhouse, switchyard, and transmission or power grid. Okay, this is the turbine and generator of a geothermal power plant on the turbine floor. Okay, the pulling out of a generator rotor for cleaning and inspection. A closer look of the cooling tower. Okay, a geothermal power plant has an emergency diesel generator set and a black start diesel generator for the restoration of the power grid in case of systems blackout. Compressed air system of a geothermal power plant consisting of air compressors, dryers, and air receiver tank. Okay, heating, ventilating, and air conditioning system of a geothermal power plant with chillers and cooling towers. Okay, this is the fire protection system consisting of jockey pump, motor-driven fire pump, and engine-driven fire pump. Okay, let's have a look of an ongoing construction of a modular diesel power plant project. Now, this is an ongoing construction of a diesel power plant modular project consisting of 162 engines with a capacity of 1 megawatt each. The location is in Barangay Malaya, Pililla, Rizal. The area is about 6.8 hectares. Auxiliaries to be constructed are the following: substation with switching and metering station, transmission line approximately 924 meters, single circuit 230 kV line to NGCP Malaya substation, fuel storage tanks, 2 units of the 3,000 cubic meter cylindrical tanks, instrumentation and control system, PLC and SCADA system, administration building and other site facilities, these are containerized, service water system, and fire protection system. Let's have a short virtual tour of wind turbine power plant. This is the Burgos wind farm in Ilocos Norte, the biggest wind farm in the Philippines. There are about 50 wind turbines at 3 megawatt each. So the total installed capacity in that area is 150 megawatt. Virtual tour of biomass power plant. This is the San Jose CTI Power Corporation, who owns a biomass power plant in Nueva Ecija. Okay, let's talk about the role of mechanical engineers in an electric power plant. Now, mechanical engineers have a special role to play in the power industry. Almost all the functions, responsibilities, and activities would require the knowledge, expertise, and skills of a mechanical engineer, especially that this industry has a lot of machinery and mechanical equipment like pumps, motors, heat exchangers, piping, bulbs, compressor, vessel, tanks, cooling tower, air conditioning, and many more. Mechanical engineers would even play a lead role in managing the entire facilities, where the other engineering disciplines look at him or her for leadership and wisdom. Now, the roles of and responsibilities of mechanical engineers are all over for all types of power plants in the Philippines, from design and engineering, construction, testing and commissioning, operations or production, technical services, performance efficiency, commercial, energy conservation, steam generator or boiler maintenance, turbine maintenance, balance of plant maintenance, control and instrumentation, as handling maintenance, maintenance planning, cold handling maintenance, reliability engineering, equipment health management, risk and asset management, asset integrity, rehabilitation, modification and upgrade, wastewater treatment maintenance, pollution control equipment maintenance, spare parts management, project management, quality assurance, quality control, and environmental health and safety. Okay, that ends my presentation. Before our subject matter experts would entertain some questions, if we still have time, just a parting words from Isaac Asimov, and I quote, "It is change, continuing change, that is the dominant factor in society today. No sensible decision can be made any longer without taking into account not only the word as it is, but the word as it will be," unquote. Thank you for the kind attention, and we hope we have enlightened you on the topics presented. The OPPSI will always be around to serve you, as they said, service above self. Again, thank you.